Hello, Year 10. Today we are going to be solving simultaneous equations using the substitution method. We're just going to do a quick review of last lesson first. Last lesson we were talking about parallel and perpendicular lines. So in question 1, we want to determine whether the line x minus y equals 4 and y equals x plus a half are parallel, perpendicular or neither. To do that, I need to find the gradient of each line. The first one is in the wrong form. I need to get it in y equals form. So I'm going to move the negative y across to the other side to be 4 plus y. And then, keeping the y positive, I'm going to subtract the 4 so that it will be x minus 4. Then I can read off the gradient, which would be in front of the x. There would be a little 1 sitting in front of that x. The second equation is already in y equals mx plus c form. So the gradient, which we call m2 of that one, is also the number in front of the x, which is a 1. Now m1 is 1 and m2 is 1. Because the gradients are the same, that means that they are parallel. Question 2. Find the equation of a line that is perpendicular to y equals 4 over 3x plus a half and passes through the point minus 4 minus 2. So this equation of the line that I've been given here, its purpose is to give me the gradient. The gradient of that line, which is m1, is 4 over 3. That would be the gradient that is parallel to that line. If I want to do perpendicular, I'm going to have to go to m2, which means I need to find the negative reciprocal. So because it's a positive 4 over 3, it's going to become a negative, and the fraction turns upside down to be 3 over 4. Then I want to use that gradient and the point that I've been given. I'm going to label it x1 and y1, and I want to put that into my point gradient formula to find the equation of the line. So that would be y minus minus 2, which makes it plus, equals minus 3 over 4 x minus minus, which makes it plus 4. Expanding the bracket, we get minus 3 over 4x. Minus 3 over 4 times 4 is minus 3. Then subtract 2 over to the right-hand side, so minus 3 minus 2 makes negative 5. Okay, hopefully you remember that. If not, there's still time to practice more if you need to. Moving on to the simultaneous equations, where today we are specifically going to be using the substitution method. There are multiple methods that can be used to solve simultaneous equations. The graphical method means you need to accurately draw the graphs and then try to accurately read off where they intersect, which can be done particularly if the point of intersection is a nice whole numbers. It does work, but if they're not nice whole numbers, it can be hard to be accurate with that method. So there are two algebraic methods, the substitution method, which we're learning today, and the elimination method. The substitution method requires you to get one of the equations rearranged to have one of your pronumerals by itself. So it says here, for example, something like y is equal to 5x plus 2. The y is by itself on one side of the equation, which means that I can sub it into the second equation. So that's perfect when you have one letter, like this one here, the y, all by itself. So having a look at our examples, question 1, this is not a typical a solve problem. This is a checking kind of question. Is 2, 4 the point of intersection of 3x minus y equals 2 and x plus 2y equals 10? Now you could just do the whole process and try and find the point of intersection and see if it did give you 2, 4 as the answer, or you can sub the point 2, 4 in and see if it actually works. If we sub it into equation 1, we would get 3 times 2 minus 4, does that equal 2? 3 times 2 is 6, minus 4 is 2. 2 equals 2. That means yes, that equation works at the point 2, 4. does the point 2, 4 work in equation 2? So that's this one's equation 1 and this one's equation 2. So let's sub that in. We have 2 plus 2 times 4 equals 10. 2 times 4 is 8, plus the other 2 is 10, does equal 10. So yes, that works as well. So because both of those lines are going through the point 2, that means that yes, both of those lines must meet at that point because they're both at that point. Okay, question 2, let's get to some more typical types of questions. We want to solve each pair of simultaneous equations by using the substitution method. So you always want to have y equals or x equals in at least one of the equations. For this one, it actually is y equals for both of them. So this is going to be equation 1, and this one's going to be equation 2. If I sub equation 1 into equation 2, that means y is equal to x plus 5. That x plus 5 is equal to the y in the second equation, which means if I write that out, I would have x plus 5 is equal to 7 minus x. And then I can solve that to find out what x is. So let's add the x over to the other side. 2x plus 5 equals 7. Then subtract the 5 and divide the 2. So x is equal to 1. Then we're going to sub that answer back into one of the equations, it doesn't matter which one, to find out what the y value is. So I'm going to choose to sub into equation 1. And I would get y equals x is 1 plus 5. That means that y is equal to 6. Now remember that this represents a point of intersection. So what I've actually found is a point where x is 1 and y is 6, where those two graphs would intersect. Let's try again for question B. We have y equals for the first equation and y equals for the second equation. So very similar to the last one, I'm going to call equation 1 and equation 2, and I'm going to sub equation 1 into equation 2. I'm going to take the 5 minus 2x, which is equal to the y, and replace it in the y for the second equation. 5 minus 2x equals 3 over 2x minus 2. Okay, now collecting the x's up, let's minus 3 over 2x. So you could use a calculator. This is a bit weird with the fractions. So you have minus 2, and you want to minus the 3 over 2. So that's a negative 7 over 2. So 5 minus 7 over 2x is equal to negative 2. Then I'm going to subtract the 5 from the front of this. So minus 2 minus 5 is minus 7. Then I'll times the 2 off the denominator, so negative 7x equals negative 14, and then divide the negative 7, which equals a positive 2. Then I sub back into one of the original equations. I'm going to pick equation 1 just to avoid the fractions. So it would be y equals 5 minus 2 times 2. 2 times 2 is 4, so that is equal to 1. So my point of intersection, and I would like you to always write it as a point at the end, is that x is equal to 2 and y is equal to 1. Question C. 7y minus 2x equals 8 and x equals 3y minus 2. The first equation isn't set up to have an x or a y by itself, but the second equation is. So if x is equal to this, I can sub that in where the x is in the first equation. So let's label, we have equation 1 and equation 2, and we're going to sub equation 2 into equation 1. So that would be 7y minus 2. The x is being replaced with the 3y minus 2. and then that is equal to 8. Expand and solve. 7y minus 6y plus 4 equals 8. 7y minus 6y is y, plus 4 equals 8. Subtract the 4, and we get y is equal to 4. Sub back in to one of the equations. Let's sub into equation 2 because the x is already by itself. And we get x equals 3 times 4 minus 2. 3 times 4 is 12, minus 2 makes 10. So that means that our solution is x equals 10 and y equals minus 4. So, not minus 4, positive 4. So 10, 4 is our solution. Question 3. For what values of k will this pair of simultaneous equations have no solution? Okay, so in order for an equation not to have a solution, that means that they are never going to intersect. The only time that lines do not intersect, so those ones would eventually intersect. The only times they do not intersect is if they are perfectly parallel. So no solutions means that those two lines have to be parallel. So let's write here, no solution, or let's say when they are parallel. Now that means I need to look at the gradients of those two lines. The first one, y equals kx plus 4, the gradient of that is going to be k. The second equation, which was 3x minus 2y equals 5, we have to rearrange that to find out what the gradient is. So let's make the 2y positive, 3x equals 5 plus 2y. Then move the 5 away, so it will be 3x minus 5. And then divide the 2, y equals 3 over 2x minus 5 over 2. So what's in the right form? The gradient of this would be 3 over 2. Now, in order for them to never touch, remember that they are parallel, which means that those two gradients need to be equal. So that will happen when k is equal to the 3 over 2. So that's your solution. Okay, put a star next to that one. That's my challenging question for the day. All right, your turn to do exercise 1I.